In this lesson, I want to see how adding or subtracting a number to a function changes the graph. So at the top here, I'm given some function f of x, and I want to see what the graph of f of x plus c looks like, and compare that to, well, what about f of x minus some number c? In example 1, we're given the graph of y is equal to x squared, and that's represented by this graph here. If I first let's look at x squared plus 5. I'm going to write this in blue. I want to sketch this equation. If we compare the two, notice that this 5 is outside of the function. So I have x squared and then we're adding 5 to it. That means we're adding 5 to the y value. So going back up to this notation, f of x represents a y value, and here we're adding 5 to it. So x squared is the y value of my graph, and I'm adding 5 at the very end. So we can use a table of values if we want to figure out what this equation looks like. So I'll just jot that below here. I'll just use a few, like maybe 3 different values. Maybe I'll look at -3, 0, and 3. If I plug this into my function, -3 squared is 9, plus 5 is 14. If I plug in 0, I get 5. And if I plug in positive 3, well, I get 14 again. And I'll plot these points. So that was -3, 14. So that's here. I had the point 0, 5. And then the point 3, 14. So what's going on here is this entire graph is moving up 5 places. So if you compare this point to this one, we started at 0, 0 and added 5 to it, so it moves up 5 places. This was the point 3, 9, and we added 5 to it, so it goes up 5 places. Same thing for this spot here. This was at x equals -3. We get 9 on the function, and then just added 5 to it afterwards. The net result here is a graph going through these 3 points that resembles the function that we started with. So that's a lot of work, but going back now, it seems like kind of obvious where if I want the graph of x squared plus 5, I just start with x squared and move it up 5 places. So you probably can guess then, well, if adding 5 went up, subtracting 5, I'm going to guess goes down 5 places. And we can check this in a table of values as well. So just to maybe get that up here, maybe I'll use -3, 0, and 3 again. It can be any points that you like. Okay, so at -3 it is 4. At 0 it is -5. And at 3, well, it's equal to 4 again. So if I plot these, let's see, at -3 it's 4. At 0 it's -5. And at 3 it is 4 again. And what happened is every point did move down 5 places from the original graph. Here this spot dropped down 5. This spot drops down 5. And likewise, this spot drops down 5 too. If I connect these, I again get a parabola shape, this U-shaped equation. I'll just kind of draw it down here just to get the idea across, but it resembles the shape of the graph that we started with, but it's down 5 places. So the idea is simple here. If I start with f of x and I look at f of x plus c, that's up some amount. If I subtract, it's down by whatever amount that is. For example 2, I'm again going to start with y is equal to x squared. That's the red graph on the axes. But this time, I don't want to change the y value. I want to try to adjust the x value. So again, we're starting with this function. In the example, it's x squared. Well, what if we then add a number not outside of the function, which changes the y, but inside the function, which changes the x? So like f of x plus c or f of x minus c. This should move the graph either left or right. So if you change an x, those are your two options. It's like going left or it's going right. And here I have y equals x plus 5 squared, and y equals x minus 5 squared. So let's check those out. So I'm first going to look at, I guess it doesn't matter which one. How about y is equal to x minus 5 squared? So I'm still referring to the function x squared, but notice the 5 is now within the function. This means the x values are changing. And you might guess that the graph would move 5 places left. But it turns out anytime that you change an x value, it will always be the opposite of what you expect. In fact, I'll just write down what this does. This is going to go right 5 places instead of left. To justify this, I'm going to look at one specific value for x. So, I'll still kind of, like, I guess, draw this on a table. But I'm going to put just one value in place of x, and that number is 5. It's an obvious number to use in this function. If you put 5 in place of x, you get 5 minus 5, which is 0. And if you square 0, you get 0 back. That's the point, 5, 0. And what happened here is this point, which was at 0, 0, it did not go left 5 places. In fact, it went right 5 places. And this is going to be true for every single point that lies on this function. So to get a couple other points on the graph, let's see. We have this point, which is at 3, 9. So I know that's going to go over to 8, 9. So I can put that point. And then the value that's at negative 3, 9. Let's see, that's going to go over to 2, 9. And the shape of the graph that I have, it's similar to the shape of what we started with. The only difference is the whole thing moved right 5 places. Now, if we compare this to y is equal to, x plus 5 squared, again, you might think, well, adding it's going to make it go 5 places to the right, but this is going to be opposite too. This is in fact going to go left 5 places. And on a table, again, I think I'm just going to focus on one particular value, and that is going to be negative 5 for x. All right, so if I use negative 5 for x and place that here, I'm making inside of the function equal 0. And if you square 0, you get 0 back. That's the point, negative 5, 0. So on this new function, the point that was at 0, 0, in fact, moved left 5 places. And that's true for every single point that lies on this function. So again, just looking at a couple familiar locations, we had negative 3, 9. So that's going to go to negative 8, 9. Then we had the point that was at 3, 9. And that's going to go to negative 2, 9. So the entire function moves in that direction. So the takeaway here is if you're changing a y value, it's going to work exactly the way you would think. It's either like up 5, down 5 if you're adding or subtracting. Whenever you're changing an x value, it will always be the opposite of what you expect. And for the last example, example 3 here, we're again starting with the function y is equal to x squared, but our goal is to graph x minus 10 squared plus 5. So I'll do that in blue. So essentially, we're taking the ideas from the first two examples and putting them together. If I look at this function, there's two things that are different. I'm changing the x's. I'm also changing the y's. That's because something is different within the function and with outside the function. From our previous work, I know that this x minus 10 in the parentheses is going to mean, well, it's going to be the opposite. It's going to mean go right 10 places. And then this plus 5 outside the function, it's going to mean go up 5 places. So those are the two things that are different. And the order in which this happens will follow order of operation. So we work within the parentheses first. So that means we're first going to go right 10. And then after we get the function, the second thing that would happen is going up 5 places. So you could even like list this in order. We're going to go right 10 and we're going to go up 5. And this is true for every single point on the function. So to do this, I'm just going to pick a couple of obvious ones to find the location in general and sketch the equation in around it. So starting with 0, 0, it's going to go right 10 and up 5. So I have the point 10, 5. So I'll plot that. And I guess I'll use 2 others. So this one was 3, 9. If I go 10 places to the right, that is now 3, 9, 13, 9. And if I go up 5, that's 13, 14, which is right here. And for one other point, just for symmetry, here we have -3, 9. If I add 10, that's going to go to positive 7, 9. Going up 5 would take me to 7, 14. And the graph is the equation that goes through these points. So I know it has the same shape of the graph that I start with, and it looks like this. So this is a rough sketch, but for all these examples, what you should do is verify this work with either Desmos or your graphing calculator so you can try those out.